Okay, so we're looking at the practice paper from the first year textbook, and we're just finishing off question 15. So I think it was, yep. So we're looking at the last question, and we've just got to do part C. So we've got our circle from parts A and B, and I've now got a quadratic, and it's intersecting the tangent to the circle at 2 points, and then I'm asked to find the area of a triangle. So the first thing I want to do, I would say, is find the coordinates of those 2 points. So I'm assuming that you've done parts A and B. So from part B, let's just remind ourselves. So we've got that equation of the circle. Oh, sorry, equation of the tangent. Okay, so we're looking at part C now. Just make a note of that. Tangent. Okay, so I'm not really looking at the full circle anymore. I'm going to do a quick sketch of what's going on here. So I know what that quadratic looks like, x squared minus 2. I know that my tangent is a straight line with a negative gradient. So I'm going to do a quick sketch of that. Oh yeah, I will sketch it roughly with the axes. So x squared minus 2 is basically the graph of x squared translated down 2. Okay, so it's just a really rough sketch. So that's going to be minus 2. Those intercepts will be plus and minus root 2 if I need them. And then I've got this straight line with a negative gradient and a y-intercept of 19 over 4. And it's going to intersect this quadratic and P and Q. So I'm going to just do a really rough sketch of that. In fact, let me just have another go at that. Because one thing I haven't thought about is where the x-intercept of the straight line is. So the x-intercept of the straight line, so when y is 0, I don't necessarily need this, but I'll do it just so I know I've got a relatively accurate sketch. So if I add the 19 over 4, or if I add the 3x over 4 over, actually, either way I get that. So the 4's will cancel, so I would get x is 19 over 3. Okay, so that just tells me that the straight line intersects, so 19 over 3 is greater than root 2. So just that's not necessarily essential, but just gives me a relatively accurate sketch of what's going on. Okay, so back to what we're actually trying to find. So the quadratic intersects the tangent at the points P and Q, and I'm going to have to find the area of the triangle POQ. So first things first, let's find P and Q. So P and Q is where the tangent, so that was our equation of the tangent, intersects the quadratic. So they're both in the form y equals a function of x. So I would say the quickest way to solve that is just to put those equal to each other. So I'll take everything over to the right-hand side. So what have I got? Minus 2 minus 19 over 4. So that's going to give me minus 27 over 4. And then you could just put that straight into your calculator. I'm going to multiply through by 4 to make it easier to factorize. So what's that going to be? I'm going to go for... so I'm going to assume that for 27 it's 3 and 9. And yeah, if I do 4 times 3 and 1 times 9, I can get plus 12x minus 9x. So x is minus 3. Oh, so hope if you could see it. Get this out of the way. Let's get that out of the way. Okay. Oh, goodness sake, right. Let's get that out of the way. Okay. So yeah, so at that point you could have just put the quadratic into your calculator and got the solutions. So your solutions are x equals minus 3 and x equals 9 over 4. Okay, right. So obviously the x is minus 3 is going to be that solution there, and x is 9 over 4. It's going to be that solution there. Okay. So now I want to think about the triangle, and I'm pretty sure so this is the triangle they're talking about. So there's the origin. So they want the area of that triangle. Okay, so I'm definitely thinking about half base times height rather than half AB sine C. I don't want to bring angles into this if I can avoid it. So I'm going to want the y coordinates of those 2 points as well. And if in doubt, you might as well calculate those just in case they're going to be useful. So I can use either equation. I actually think the quadratic, I'm just going to use the quadratic one. So when x is -3, y is 9 minus 2, so 7. And when x is 9 over 4, I'm going to put that in the calculator. So 9 over 4 all squared minus 2 gives me 49 over 16. Okay, and then now I'm going to draw another just quick sketch and have a think about how to find this triangle. So I've got the coordinates 9 over 4, 49 over 6, so not to scale. I'm going to put that roughly there. And I've got the coordinate -3, 7, and 49 over 6 is a little bit greater than 7, so that's about there. Again, very much not drawn to scale. Okay, and that's the triangle I want the area of. Okay, so there's going to be various ways of doing this, I'm sure. You might even think of a slightly quicker way. I've not got a right angle triangle. So I think how I'm going to tackle it is I'm actually going to split it into 2 triangles. So yellow probably wasn't the best colour to use, but we'll go with it now. So I'm going to do that triangle and that triangle and add them together. So the reason I think, so that's all I need to see for this. The reason I think this is my best method is I want to use area is half times base times height. And I know what that coordinate is because that's the y-intercept of the tangent. So that was the equation of the tangent. So I've got the y-intercept. So I know that that's 19 over 4, okay? And that is going to be the base of each of the triangles. So what do I need for a triangle? I need base, oh, I don't know what happened there. I need base times perpendicular height. So for the yellow triangle, the base is 19 over 4, and the perpendicular height is just going to be the x-coordinate. So it's obviously the x-coordinate is -3, but in terms of the length, that's 3. So stick that into my calculator. So 19 over 4 times 3 times a half. So that gives me 57 over 8. And for this triangle, and again, it's the perpendicular height of the pink triangle is also just going to be the x-coordinate. Okay, it doesn't matter that it's a sort of scalene triangle that's sort of going off to the side there. That is still going to be the perpendicular height. So I'll call that one area 1. And now I'm working out the area of the other triangle. So that's going to be half. So the base is still 19 over 4. The height is the, use the wrong coordinate there. The height is the x-coordinate. Yeah, that's the height of the triangle, which is the x-coordinate. So 9 over 4. So 19 over 4 times 9 over 4 times 0.5 is 171 over 32. So the total area, hopefully, check if this works, 57 over 8 plus 171 over 32 gives me 399 over 32. So fraction in its simplest form. Okay, so they've got it as a mixed number. I've just double checked and I'm very relieved to say that that is the same answer. Okay, and let's just double check the wording. Yeah, so simplest form doesn't imply a mixed number. So if we'd have left it, as long as 399 over 32 doesn't simplify down, which it doesn't, obviously you can just pinch your calculator, either of those answers would be absolutely fine.